All right, let's break down gradients. Sounds complicated, right? But it's actually pretty intuitive.
We all get how slope works on a 2D line, but what about on a 3D surface, like a hill?
Right. Going straight up a hill is way steeper than, say, walking sideways across it.
Exactly. So for a surface like this, slope isn't just one number. We need a new toolkit. Let's start simple with our first tool, partial derivatives. They just look at two directions.
The partial with respect to x just tells you the slope if you're only moving east or west.
And, you guessed it, the partial with y gives you the slope moving purely north or south.
Okay, that's useful. But what if I want to walk diagonally? This doesn't help me yet. For that, you need the master tool. It combines these simple ideas into something powerful, the gradient.
See that symbol? It's called del. The gradient is just a vector that packs both partial derivatives together. So a normal derivative is just a number, right? A slope. But the gradient is a vector. It has direction.
And here's the magic. That vector always points in the direction of steepest ascent, like a compass for climbing.
Plus, the length of that vector tells you exactly how steep that climb is. Pretty cool, huh?
So now we can finally find the slope in any direction, not just north-south or east-west.
You take the gradient and do a dot product with your chosen direction. That gives you the slope.
But wait, there's more. The gradient isn't just a slope calculator. It tells us about the surface itself. It helps us find the tangent plane, a flat surface that just kisses the curve at one point.
Turns out, the gradient is the key to defining that plane. So slope and the local flatness are linked.
Okay, why should you care? Well, this whole idea is the engine behind a lot of modern AI. It's used in something called gradient descent. Instead of climbing up, we want to go down. That's how algorithms learn. They just take tiny steps in the opposite direction of the gradient to find the lowest error point. So this little mathematical compass isn't just for hills. It's fundamental to finding the best solution for tons of problems.